Okay, welcome back to another week of design lessons for robotics. This week is going to be a little different. We're going to do some in-person stuff today, and we're going to show you how to design something for an actual part in person, the whole process. I say that it's not going to be that long. We're going to be here for about 5 minutes. We're going to go all the way to sending it to the 3D printer. We have one of these wooden shafts here, and we're going to imagine that we have another wooden shaft that's going to want to connect to this. So all we want is a simple like butt joint connector. So it's going to slide over this end, it's going to slide over the end of the other one, and it's going to connect the two together, which is a super simple one-sided connector. So we have our calipers here, we have the rod, we have Fusion open on our computer, and let's get started. So first, I just have a blank document here. We're going to create a sketch on the bottom plane, and I'm going to press C for circle. We're going to open that up. We're not going to type in a measurement yet. We're going to go back to in person here. We're going to turn on our calipers. We just want to check what the diameter of this rod is. So we can see it's about 16.8, 16.83, 8.5. Now, when 3D printing, measurements don't have to be super accurate because the 3D prints are going to expand and contract a little bit, and I'm going to tell you what those numbers are going to be. So as I'm rotating around this rod, I can see that it's not perfectly circular. We're getting from 16.7 all the way up to 16.85. So I'm going to use 16.85 as my measurement. Back in Fusion, we're going to go 16.85. This is the exact size of our circle, which means if we print a little adapter that's the exact same size, the 3D print, again, it expands just a little bit on all the walls. So this would be a very tight fit. It would be a one-time fit. You're never going to get it out. What you can do is you can double click on the dimension here, and you can just go in here, you can just add stuff. So I can go add, and for a nice tight fit that's still removable, not just a one-time use, we're just going to add 0.1 millimeters to the whole circle, which means that we're actually going to want to add 0.2, because if we just add 0.1, it's a circle that's got two sides. We're working on the diameter here, so it would add 0.05 to this side and 0.05 to this side. So to add 0.2, it'll actually be 0.1 bigger all the way around. So we're going to press enter there. That's our whole size. And now my idea for this little coupler here is it's just going to wrap around maybe about 2 centimeters down, and we can play with that dimension. See, now that I'm looking at this in person, I see 2 centimeters, and I think, that's not long enough. They might still wiggle a little bit. So I'm actually going to go up to 25, so 2.5 centimeters. And so we'll keep that measurement in mind. We're going to go back in Fusion here. Now with this base circle, I'm going to want the thickness of the 3D printed wall. Usually the minimum wall I'll go is about 2 millimeters. All the way up to 5 if I need something super thick. This one I'm going to go 2.5. This measurement, again, is just kind of the strength you want on your part. So I'm going to finish that sketch, and to orbit around, I'm just pressing Shift and middle click, and that'll let me orbit around in 3D space. You can see up on the top view cube, it's rotating. Now I'm going to press E to extrude. Again, we said we wanted that 25 millimeters, so we're going to do 25. We're going to press OK. So this will slide onto one end of the shaft. Now, because we don't want it to slide all the way on the shaft, we just kind of want to stick it on the end. What I'm going to do is I'm going to rotate to the bottom here, and we're going to extrude both of these down about 3 millimeters. Sure, that's perfect. So we'll click 3 there, and now you can see if I turn off the sketch on the left side here, we can see that it has a cap. So the stick will only go in so far. Now what I also want to do is I want to find a spot for the other stick. So I'm going to press E to extrude again. I'm going to hover over that sketch profile. Make sure you're not on the bottom of the plate. You don't want to extrude this whole circle. I just want to extrude that one part of the sketch. If it doesn't let you select it, you can always turn the body off on the left side here. Select your sketch, and then turn the body back on, and it'll let you select whatever you like. Now I want to also go 25 down, but if I go 25 down, it's that 3 is getting in the way. So there's going to be a couple ways you can offset this. One, you can just add 3 of this. We can go 28, and then you can set it to join, and that'll be 25. If you don't want to do math though, what you can do is you can set it back to whatever the default is. And on the right side here, we can say offset, and you can set an offset of -3. And now we can go back to our 25. And what that does is it starts our extrude from that 3 millimeter offset. So we can go up, we can go down, and it kind of resets the base of wherever that extrude is starting from. So we're offsetting at -3, so it's just going to start 3 millimeters lower from where we actually have the profile. So we're going to go 25 down from there, and that's our part. Now, on this last extrude, I did something wrong. And you might say, oh, why is there this line here? And on our left side, you can see we have 2 separate bodies. And what's happened here is in this last extrude we just did down on our timeline, we can see that the operation was new body and not join. So you can see when we join, now it's going to create one solid structure. When we click new body, it's going to extrude this and make Fusion think it's actually a different part, which we don't want. So we're going to go into the extrude, we're going to change it to join, we're going to click OK. Now if we turn off our sketch here, we can see this is exactly what I was looking for. Super simple. It has spots for both of the wooden dowels to fit into both ends. It should fit because again, we added that little tolerance back in the sketch. This is just that 0.2 millimeters bigger. That looks all good. Now, just for looks, to make it a little cleaner, I'm going to press the chamfer tool. This just kind of puts like a little cut on all our edges. I'm going to do that. I'm gonna set it to 1.5. That might look good. And I'm actually gonna go 2 distances, and that'll let you change the distance. So I'm just gonna do that. Again, this is just for cosmetic reasons, so it has no functional purpose at all. Actually, technically it makes it weaker, but I think it looks cooler. That's always a good thing. So yeah, chamfer is gonna be a really handy tool. I always love cutting my corners. And now last thing we gotta think about is 3D printing, because we're gonna print it like this. And what's gonna happen is, I'm just gonna use the analysis tool here. It's gonna start at the layer, and 3D printers print in layers, right? So it's gonna start at the bottom, it's gonna slowly go up and up and up. And as soon as it reaches here, it just had to bridge across this whole gap. Now, if this circle was any bigger, I'd say we might wanna do something about that. We might wanna maybe put a cut corner on the inside just so it has to bridge a little bit smaller, or maybe we have to use support material. Because this is only 16 millimeters, my printer can handle that, that's okay, I'm gonna leave it. And I'll show that in the slicer as well. This is gonna print totally fine. I am gonna put what's called a brim on it in the slicer. So that's our part, it's done. It looks great. Now, to get this into the slicing program, we're just gonna right click again on this body here. This was in a previous tutorial, if you remember, a couple months ago. We're gonna save as mesh. We're gonna export to an STL in millimeter. I'm gonna save this, and then I'll open it up in Prusa Slicer and catch up with you guys. Okay, here we are in the slicer. I've just imported it again with this add tool up here. Here's our part. This is what it's looking like. So again, basic settings, we're just gonna go 0.2 millimeter layer height. Very standard. Again, like I said, I'm gonna add that brim, which is just gonna add a little extra support on the bottom here because our bottom surface area is quite small. I'm not gonna change much else. It's a very thin part. It doesn't have to be super strong. I'm not gonna worry about too much else. We're gonna click slice. We can watch through and see right here on this layer right there. So you can see it's gonna bridge across this gap. And again, because it's small enough, and again, because it's on the inside of this part, I'm not too worried about it. It should be quite a simple print for it to do. This looks great. That's the whole process. I'll print it out and show you when it's done. Okay, here they are just off the printer. As you can see, they turned out exactly like we modeled them here with the chamfer on the edge. They have that cap at the bottom and they look pretty good. Now, the main thing we wanna check for first is if our tolerance fit. Perfect, not too loose, it comes off, it's a tight fit. Again, that's that 0.1 millimeter gap all the way around. We increased it by 0.2, that's perfect. I printed 2 of them off because I need 2 of them for this thing. It's not just one useless part. Obviously you don't want to waste plastic. This does have a purpose for a different totally random thing. I just thought I'd use it as an example because it's quite simple and that tolerance works perfect. Works great. Anyways, that's how you model a part from start to finish, and hopefully that was helpful in some way, shape, or form. That's it.